3.3 is on division of polynomials, remainder theorem, and factor theorem. So let's take a look. First, we want to let f of x be a polynomial. And we're going to assume that d of x, also a polynomial, but it's non-zero. Then we have, if you take a polynomial, f of x, and you divide by d of x, another polynomial, what you end up with is a quotient, q of x, plus r of x, which is the remainder, divided by d of x. Or you can multiply that out. You can write the polynomial f of x equal to d of x times q of x plus r of x, which is really what we're after, is this form. So let's just review some terminology. F is called the dividend. D, the divisor. Q is the quotient. And R, the remainder. Which would be the same terminology if this was just numbers. Like if you did long division of just regular integers, then that would be the same terminology. So what we want to look at is long division of polynomials. And go through that. And then ultimately, we want to go through what's called synthetic division is our goal. So let's just jump right to an example. Let's suppose we take 2x cubed minus 11x squared plus 13x plus 15, and we're going to divide that by 2x minus 5. Then, what we have is this form. This is the polynomial in question. That's like f of x. This is the divisor, d of x. And so you want to do that long division. Now, if you recall just regular numbers for long division, you put the divisor first. You say 2x minus 5 divided into all of the rest. So all of this. And you copy it, but I can duplicate it, put it here. Okay. And then for long division, many of you will remember how to do this. This is algebra stuff. We say what times 2x is 2x cubed. So what times 2x is 2x cubed. So you already have the 2 there, so it's just a 1. And then x times what is x cubed? Well, that has to be x squared. And then you multiply x squared times each of those and put them under here. So this 2x cubed must be the correct thing. And then minus 5x squared. And then you draw your line and subtract. And so the sign changes get to be an issue sometimes, so be really careful here. So it's like you distribute the negative and then you add. And so that becomes of course, this is 0. That's what we wanted to have happen. This becomes a plus, and then you add. So you get negative 6x squared, and the rest are 0, so you bring those down. So it's plus 13x plus 15. And then you ask the same question, what times 2x is negative x squared? Okay, do you have it? It's negative 3x. Then you multiply, and you get negative 6x squared. And you do the multiplication in your head, but you actually need to think about that. Like, what is it? And then 3 times the 5 is 15, which is positive. So it's positive 15x. And then you subtract that. So you change the signs and add, and you get 0, of course, and then negative 15 plus 13 is negative 2x. And then we bring down the 15 plus 15, like that. And we have one more value to go, because that'll match, so it's just going to be a constant. So what times 2 is negative 2? And then it's an x, so it's just negative 1. So it's negative 2x plus 5. And then we subtract. And so you get 0, and then 15 minus 5 is 10. All right, so this is your r of x. That's your remainder. So when you write out this form, remember it's this form here. So that form, put down here, I'll just do this once. I'm not going to keep writing it like this. So you get your f of x, which is this. You get f of x, and then it's over the divisor, which is the 2x minus 5, and then that equals the quotient. Well, the quotient is this. And then plus the remainder over the divisor. All right, so let's write that out. So you get quotient x squared minus 3x minus 1 plus the remainder, which is just 10, over the divisor, which is the 2x minus 5. And there we go. Now, that's all well and good. That's really not why we're doing this. We're doing this because we really want to find, in the long run, we want to find when the remainder is 0. And then by doing that, you know how the polynomial factors. So that's really what we're after. Now, it'll take maybe a little bit to get to, but that's what we're after. Okay. So I want you to try this one. The next example. I want you to do x to the 5th minus 2x to the 4th plus x cubed minus 8x plus 18 divided by x squared minus 3. So set that up in your long division form and go ahead and do that long division and try that. Okay, and then we will I'll basically tell you the answer. So we'll just do the quotient this time. Quotient ends up being, okay, so assume you've done it, x cubed minus 2x squared plus 4x minus 6. Okay, so that's your q of x. Okay, so try that and make sure you have that. You ask me questions or look stuff up later if it's not making sense. So when you do this one, here's a little note. You stop doing the division, so stop when the divisor has a smaller degree than the remainder. And that's what will happen when you go through this. Just to verify your remainder. What's your remainder? Anybody got that one? You end up getting r of x is equal to 4x. And then you can see that 4x is smaller in degree. This is degree 1 than your so stop when your divisor has a smaller degree than your remainder. Actually, reverse that. You want to stop when your remainder has a smaller degree than your divisor. So I need to flip that around. So stop when the divisor, I say remainder. So stop when the remainder which is 4x, has a smaller degree than the divisor. Okay, sorry about that. Okay, so next, let's do synthetic division. And so this is a special case of long division. So this is dividing, I'll abbreviate here, dividing polynomials by synthetic division. And, you know, the word synthetic division is really just a name. It doesn't have anything to do with it being synthetic. It's just another way of organizing how you do it. So, but that's still what we call it. So, so one of the key factors here, and write this down, this only works on dividing linear factors. So x cubed minus 13x squared plus 46x minus 49 divided by x minus 8. So linear factors has to be in the form x minus c. So if you have x plus 4, then your c is negative 4 because it's a minus minus. If you have x minus 8, then c is 8. If you have x plus pi, then c is negative pi. Okay, so this is how it works. What we look at are these coefficients and C. You identify C and the coefficients. So you write C, which in this case is my 8, and you put then little mark like that. And then you write down the coefficients of the polynomial and make sure you put in missing degrees. So this is 3, 2, 1, and there isn't anything missing, so that's good. So this is 1, negative 13, 46, and negative 49. And then you leave one character space right here and draw a line like that. And then you take your 1 and you bring it down. So you take the 1 and you put it here. And then you multiply 8 times the 1 and put it here. So 8 times 1 and place it there, which is 8 in this case. And then you add those two together and you get negative 5. And then you do it again, 8 times negative 5 and put it here, which is negative 40. And then you add, put it here. Okay, now the last one is going to be your remainder. So 8 times 6 is 48, and you add and put it there. So your remainder, R of x, is negative 1. So your form then, f of x over d of x, is the quotient. Now you put this in the quotient form. It reduces this by 1 degree. So put that down. So this reduces by 1 degree. So by 1, right? So this was third degree. Now this is second degree. So this is 1x squared minus 5x plus 6. And then it's plus the remainder, which is negative 1, over the divisor, which is x minus 8. And I always like to say plus here, even though you can move the negative over, but that's how I write it. Okay, so try this one, which is x to the 5th minus 3x to the 4th plus 12x minus 33 divided by x minus 3. So let's identify a few things for you. So C is your 3. So you're going to say 3 here, and then 1, and then negative 3. See, now you have to put in what's missing. The third degree term is missing. 5, 4, there needs to be 3, 2, and then here's your 1 and constant. So those need to be zeros. So this is x to the 5th, 4th, 3rd, 2nd. And now you put in your 12 and your negative 33. 1 character space. And then that last one is always your remainder. Okay, so try that one. And then I'll just do it real quick because it's pretty fast. See what you get. Pause it. Okay, bring down the 1, multiply, 0. And then multiply, you get 0, 0, 0, 0. 0, add, and you get 12. Multiply, you get 36. Add, you get 3. So there's your remainder. So this becomes, it was a 5th degree, now it's a 4th degree, plus 12, and then plus 3 over the divisor. Okay. So the remainder theorem we will be using this concept is that if a polynomial function f of x is divided by x minus c, then the remainder is just f of c. So it's like you can evaluate the function at a point c by doing this long division, which is in some synthetic division, sorry, which in some ways is easier than actually plugging it in and evaluating. Now, what that tells us is that we can use the factor theorem instead. Well, not instead. We use the factor theorem to find roots of polynomials. So this is really what we're after, is that combined with the factor theorem. And we're really after zeros. We want to find the zeros of those polynomials, the roots. So 1, it says, if f of c is equal to 0, that's the definition of a root, then we actually know that x minus c is a factor. It goes hand in hand. So if you think about how a polynomial factors, if it's a 0, then it has to be a factor. Like that's what you get when you factor a polynomial. Okay, and it goes the other direction as well. So this is what we call an if and only if statement. If x minus c is a factor, then f of c must equal 0. So check out what happens. I mean, it's really to do with this form. We have f of x equal to d of x plus q of x plus r of x, the remainder. And we have that d of x is equal to x minus c. Then you end up getting this divisor is x minus c times q of x, which is what we have, plus r of x. But r of x must be 0 since f of c is equal to 0, meaning it's a factor. And so you basically just factor the polynomial. You just get x minus c times q of x. So if it's a factor and you have f of c as 0, then you get just this. Well, if by the remainder theorem it's 0, right? So f of c is 0, which means it's a factor. Well, then this disappears, and you end up just getting that. That's what we're going to be doing when we solve these equations and apply it, basically. So, let's see. All right. We'll have to review complex numbers and synthetic division in a separate video because we want to get on to 3.4 or zeros or roots of polynomials, which will help us do more of the things for the future. Okay, sorry for moving that around. All right, so next will be 3.4, and then maybe come back and do another video on complex numbers.